Evaluate the integral and identify if it converges or diverges. And this is our integral, which is x times e to the x dx from negative infinity to 0. One thing to note, this is a type 1 improper integral because there's an infinity bound. Let's just rewrite this real quick right here. It's going to be super simple. It's the exact same thing. I'm just rewriting it to clarify. And we're going to apply the limit for this integral, which is w approaches infinity. Which is now, since it's approaching to infinity, we can substitute infinity in our integral. So let's say x e to the x dx as per said here. And we're gonna substitute negative infinity to w. So it's now negative w. And 0 is still 0 as just a regular bound. Okay, now that we have that, we can now solve the integral. And this is an integration technique, which is something that you guys should know. It's by parts. And by parts, in order to do this, we must follow the acronym LEAT, which is logarithms, inverse, algorithmics, trigonometry, and exponentials. And what we have right now is an algorithmic and an exponential. Based on LEAT, we must prioritize what comes first, and what does come first is algorithmics. So that means u must be prioritized by x. That's an algorithmic. And dv is whatever's left. Ex dx. And to continue, we're going to find the derivative of u. So du will be dx. So that's the derivative of x, which is 1. But then again, we can't just put 1. So dx. Now we are going to find the antiderivative of dv. So dv is going to be v. And antiderivative of e to the x dx is e to the x. Remember, we don't need to do a plus c here because it's unnecessary. Now that we have that, we can use the ultraviolet voodoo, as some people would say. It was just uv minus integral of v du. Substitute everything. So u is x, v is e to the x, minus integral of v, which is e to the x, and du is dx. And then we can keep going. Also, a quick note, I set the bounds and the limit aside for now because we're just going to solve the integral. We're going to come back to that right after we finish this, which is this last step. So x e to the x, and we will solve the e to the x integral, which we've done already with dv and v. It's kind of the same thing, which is e to the x. So there is our integral x e to the x minus ex. So let's apply everything back together. Limit of w approaching infinity. We're going to do brackets now, which is x e to the x minus e to the x from negative w. Remember, it's w. We're not going to do infinity for now. To 0. Okay. We can now apply the bounds. Let's not apply the limit just yet. So make sure you still set the limit throughout. So starting from the upper bound, which is 0, it's going to be 0, e to the 0. I know it's going to be 0. It's going to end up at 0, but we're just going to put it in to clarify. And it's subtracted by e to the 0. Close bracket. Now that's the upper bracket. Let's subtract it by the lower bracket, which is negative w e to the negative w minus e to the negative w. Alright, let's simplify. Limit w approaches infinity. It's going to be this 0 minus, this is minus 1. So minus 1, it's a big eraser, plus w e to the negative w plus e to the w, negative w. And you might understand why it's positive, because we're foiling this negative sign to each other. which is why they're both positive. Now that we have this, we can now apply the limit. So negative 1 is still going to be negative 1 because there's no w, so nothing's going to change. Now this one gets interesting. This is going to be infinity e to the power negative infinity. Now we're going to write this aside. We're going to do e to the infinity. So I'll put this 2 for the top, e to the negative infinity, because that's going to end up being the same result. So e to the negative infinity, you can rewrite this as 1 over e to the infinity. Remember your inverse. Now e to the infinity is going to be infinity. And it's going to be over 1. And anything over 1 divided by infinity is actually going to converge to 0. So imagine infinity as an extremely large number, which it is. The number would end up looking like 0.000000000, you know, and then there might be an end, like a 0 1 at the very very end, which is way far down, right? But that number is gonna be super super little, so you can really assume that it's gonna end up as 0, which is why it converges to 0. But yeah, setting it aside, that's gonna end up as 0, meaning e to the negative infinity equals 0. So let's call back to this now. So it's going to be negative 1 plus infinity times 0 plus 0. Infinity times 0 is kind of the same thing as any other number. Anything multiplied by 0 is going to be 0. So our answer is going to be negative 1. That is our limit. Now the other question is, does this converge or diverge? This is a real number, so therefore it converges. And if your teacher probably wants it or not, you can say it converges to negative 1. We can say it converges, and I think that's good enough. And if you want a cleaner answer, I'll just do this. This is also proper answer. There you go.